So now let's move on to our first algorithm in greedy algorithms. After greedy algorithms, that is Snapsec algorithm, Knapsack problem. Okay, so Knapsack problem has two types. It can be solved in greedy method also and dynamic method also. So here we will take greedy method. Greedy method, the difference between greedy and dynamic is that greedy method it is fractional knapsack. Okay, what I have to everything. So let's say a thief enters to your house and he or she wants to take the maximum amount of profit from your home. So here there are two points, like profit is there and weight is there. So how can he get the maximum profit? It is really about profit. Okay, let's say he or she is really about profit. Like he wants to make the maximum amount of profit from, like a heavy material can be of less worth, but a small material can be of huge worth. So that in that way, it is basically asking for maximum profit. How can he or she earn from your home by stealing from you? So here in greedy way, he can break the item and take a part of it. Let's say if his sack is weight, here weight, you say you have taken three objects and weight is like his sack's weight is 20. Weight is 20. This is weight and this is number of items here present. Okay, so how can he feed 20 in the maximum profit way? That is the main logic behind this algorithm. Okay, so how can he make the maximum profit? Even he can break some item and place it here, because his weight he can take maximum of 20, because he mentioned 20 is his maximum weight he can carry the items. So now let's see. So how it can be done? So he is greedy about profit. So let's say this is profit of object 1 25 and its weight is 18, and profit of object 2 is 24 and its weight is 15, and then profit of object 3 is 15 and weight is 10. Okay, so next step we have to find is profit by weight, pi by wi. Let's see. So I'm not good at calculation, so I have done it 1.4, 1.6, 1.5, 1.4, then 1.6, and then 1.5. Means 25 by 18, 24 by 15, 15 by 10, like this. Okay, so now yes, so now he has to this is the profit by weight ratio. Okay, so this is py by wi weight ratio. Now next step is we have to do is sort this profit by weight ratio in non-increasing order. So it's very important, we have to sort this profit by weight ratio in non-increasing order. So non-increasing order means here highest is 1.6, right? 1.6 will become coming first, then 1.5, then 1.4. You can write, see, we are not here for semester exam that we have to write everything down. So in semesters you have to write this lengthy statement, but here is how we can solve the questions efficiently and with time, proper least time, but not doing any miscalculations or errors. Okay, so that is the main point in here. Okay, so you don't have to write anything about these statements. So now this is way you can also write it like object 2, then 1.5 is object 3, then 1.4 is object 1. So now here this in this way it is sorted in non-increasing order. So now let's see. First we have to take object 2, because that is the one in non-increasing order. So let's say object 2 is taken. So here total capacity is 20, means the weight is 20 and object 2 has got 15 weight, its weight is 15. So 15 is blocked, so 5 is left, and please write object 2 here. So here object 2 is written, so this is done, this is taken, let's put a tick here, like I used to do, I used to put some tick here. So now 5 is left. Now let's see, 5, none of its weight, this object 1 and object 2 weights are greater than our already existing. So he can break the item. Let's say the weight of this is 80 and 10. He can take 5 of 18th part or 5 of 10th part. Okay, so like this you can say. So our next is 1.5. 1.5 means this object 3. Don't put first here this step. First step means you are done already. So let's say here we can take 5 of 10th weight and profit will be 15. Okay, so here let's just put it here. Okay, so sorry, profit we have to calculate. Okay, so the profit of previous one was 24 and now profit is 7.5. Like this 5. So this is our profit. This is the highest profit we can get from this algorithm. Okay, so we can take more examples and we will see. So now I will tell you again. So maximum weight we can have was 20, and then after 15 was taken, so only 5 of this weight was left. So in 5 the next profit by weight ratio we have to take is 1.5. 1.5 means object 3. Object 3. In object 3 we can take 5 of 10 weight into our profit. So this coming down to 7.5. This is our profit we are taking. So now let's move on to our algorithm. So then we will take more examples. There are a lot of PYQs there in knapsack algorithm only. So we'll do that. So please keep watching. Okay. Now let's see the algorithm here. Okay. So I have just given you the idea how this algorithm works. Now we'll see how let's see the algorithm. See, even if you don't understand now, I will tell you to write this down, because it is just the way you should do, because writing algorithm, and so you don't need to worry. Even if you know semesters you have to write all the algorithms, but when you are comfortable with all this, you can easily write it down on your own. Okay, so it is just in your own words you can write it down. It's nothing much. So you just need to practice. Okay, how I became efficient in all those algorithms is that I practiced a lot. That's how I am like now I am making videos. I don't need to prepare anything. I just make videos. Okay, so this will be your case also. You just need to practice. It's nothing like you have to have this high level IQ or something. It's nothing like that. Just you have to practice. So it's the only key. Okay, so now let's see the algorithm. So here, greedy knapsack, this is our function. Okay, so this is our function here it's taking. So from for I equals to 1 to n, we are computing Pi by Wi. If you remember, we are computing the profit by weight ratio. Okay, so this first part, if you remember, see, I will do another problem and then PYQs, but still, if you can relate to the previous one, if you see, let's see, still. For I equals to 1 to n, we are computing the profit by weight ratio. This is computing the profit by weight ratio. Sort the objects in non-increasing order of P by W. Okay, so here sorting algorithm is used. See, we have taken so many sorting algorithms. You can take any one of this. So any sorting algorithm will work. Any sorting algorithm will work. So now let's see. For I to n from the sorted list. So now we have got the sorted list. We have used some sorting algorithm. Now we have the sorted list. So now for I to n from the sorted list. See here, if you remember, if the weight always the capacity should be greater than 0, because the left capacity, we are putting some weights inside our sack, so the weight has to be more than 0, so that only that in that case only we can put more items to that sack of ours. Okay, so weight has to be greater than 0 and okay, so this is and means we have to check both the conditions. So if the weight, which weight we have next is less than our weight left from this sack, any weight left which is less than our, see, in our previous example, if the weight was less than the maximum the weight capacity present, we can just do, what we do, just minus the weight, the capacity minus the weight incoming, and then we are just increasing the profit of its profit. Okay, so if this not is the case, break the statement, and if n is greater than 0, because we have seen this is our fractional knapsack. Okay, so we can break the item and we can take a part of it. So it is just profit plus profit of that element of that weight you can take by the weight of that element. Okay, so like this, the amount of weight we can take, let's say 2 was our, previously 2 was our remaining weight was there, and total weight was 218 was there. So you can take this in fractional weight. Even if it's still not understanding very well, I will tell you in proper way when we do another question. Okay, so now let's check the time complexity here. So for this computing of this, it will take order of n, because for n times it can run, so it will take order of n, and any sorting algorithm we are taking, it can take order of n log n. Okay, and all this will take order of n, and this will take just order of constant time. So among all this, which is the highest? N log n. So n log n is highest, so it is our time complexity. Time complexity is order of n log n. So this is highest because this sorting algorithm we are taking n log n. This is n, and n log n. N log n is highest, so we take n log n. So this is our time complexity. Let's move on to more examples, which in that way it will be more clearer to you. Okay. So now let's see this example. Okay, so these are all, see, total weight of our knapsack is 15, and there are 7 items. So 1, 2, 3, 4, 5, 6, 7. So there are 7 items, and objects is this, profit is given, weight is given. So this was not given. Okay, profit by weight ratio we have to find it out. So I have done this before because I'm not good at calculations, so I have written it out. Now let's see the algorithm and then do this question. Okay, so now first was for I to n, for 1 to 7, compute vi by wi. They are computed already. Let's say vi by wi we have computed. Okay, so now sort the objects in non-increasing order. So non-increasing order means we have to take the highest one first. So object we are sorting in non-increasing order. So 6 is our highest. Okay, so 6 is our highest. So means object 5. So this is taken. Then 6, then 5. 5 means object 1. Then 4.5 means object 6. 4.5 is taken. 5 is taken. Then 3, 3 you can take it's better take the list. What this is this process and process ID and all we are doing. We will doing operating system. So let's take this. Okay, 3, and then object 7. 3 is done. 1.6 means object 2, and then 1 means 4. Let me check once. Yes, it's okay. So now we are done with this sorting part. We are done. So now for I to n from sorted list we have to do this. Basically this is our main part. This was also our main part. When you do somewhere wrong in this step, you might get wrong answers. Okay, so now let's see. So our knapsack is here. Let's say this is our knapsack and capacity is 15. So now we have to take the maximum, we have to put in this knapsack and then compute this part. So now m is greater than 0, yes, m is greater than 0, and then wi means here object 5, object 5 means here, let's come here. So the object 5, 1 is less than equals to our total color. So object 5. So object 5 means here. Okay. So its weight is 1. 1 is less than 15. So yes, it is true. We can do the next two parts. So we have to put the object. Object 5 is put here. Object 5 is put here. Okay. So now object 5 is put here. Now we have to see. We have to take the minus. We have to see. We have put something in our knapsack. Now we have to decrease the weight. Weight is decreased by 1 because its weight was 1. So now profit. So profit was initially 0. So now profit will be here Object 5 profit was 6. So this is our profit. So now next move on to our next. See, this part will run. See, for 1 to n. See, this will run up till this part is broken. This if part is broken, any of this case is broken. So we will move then break the statement. But now for now it is running this if part only. So now let's move on to our next. So 5 was taken, 5 is done. So now 1. First object is taken. First object, it has got weight 2. So we decrease the weight by 2. It will be 12. Okay. So we are taking object 1. These are objects. Okay. Object 1 is taken. So its profit is 10. So now this is also done. 1 is done. Next is object 6. Object 6 is here. So its weight is 4. So 12 minus 4 is 8. 8 is there. And object 6 is placed in our knapsack and its profit is 18. Then we are doing. So now our next is we are done till here. 6 is taken. Now object 3. Object 3 means here. Object 3's weight is 5, which is less than our weight. So object 3 mass is already greater than 0, and object 3's weight is 5, and our object human weight is 8 here. So 8 minus 5, 3 is left. Object 3 is put here, and now profit is 15. So plus 15. Now next 3 is done. Click here. Now object 7. Object 7. See here. Object 7's weight is 1. So weight is again less than 3. So 3. 1 is decremented from this. 2 is left. Its weight. Object 7 is put here. And now we increase the profit by 3. So now this is also done. So now we are left with 2. Weight is 2 here. And our next 7 is taken. So object 2. Object 2 here. See, now weight is increasing. Weight is 2 is our capacity, and now its weight is 3. So here this condition is breaking. The weight incoming weight is not less than it is 3, and this is 2. This is what is this is getting out of the loop because it is false. So see, and is present. So any one of this cannot be. If any one of this is false, we are breaking this loop. So we are going out of this loop to this. Break condition is done. Then if mass is greater than 0, yes, mass is greater than 0, it's 2. 2 is greater than 0. So now here we have to do this. Okay. So profit was this already. Then we have to put 2. Okay. So 2. Only part of this object 2 will be placed. See, profit. Its profit was what? 5. 5 into how much part of this is 3? 3 of this 2. Okay. And we take it. Sorry, I just of this something else. So 2 of 3, not 3 of 2. 2th part of this 3. Total 3 parts are there. We can take 2th part of this 3. So this is our profit. Let me check after this what is correct answer. 55.3. Okay. 55.3 is our profit. So maximum profit is taken. So this is how it is coming. I hope you have understood this. See, it may take some time to be efficient with this because there are so many parameters we have to check. But you can see how this algorithm we can just do it here. So you can just write your algorithm by your own. It is nothing to you have to remember. See, in semesters also this you don't have to remember all this. You can just write it. Once the concept is inside your head, you can just write it on your own. So nothing much about it. And for examples, we will take more examples and we will see. Okay. So for now, just copy it down and please do it on your own also. And now let's move on to some another example with which you will be more efficiently. You can do more examples. So one way to do only this is take more examples, do this, practice this questions. Only then you will be then you can do any questions. It will not stop you from doing any questions. Okay. Now let's move on to next. I will now do another question. So now again this next question, this is taken. So here weight is 15, total capacity of the knapsack is 15. 7 was previous. Now it's number of elements, objects are 5. Okay, not elements, here objects are 5. Its profit is given to 28, 25, 18, 9, then weights 1, 4, 5, 3 and 3. Okay, so now we have to compute. First line was compute Pi by Wi. I've already done that. So now here we have to do it, sort it in non-increasing order, means highest will be taken first. So 7 is the highest here, among 1, 7, 5, 6, 3. 7 is highest. So 7 is taken, means object 2. These are objects, okay. Objects are stored in like this. 2 is taken. Then 6 means object 4. Then 5 means object 3 here. Then 3 means object 5. And then lastly 1. So this is our sorted order. Now we will do this, complete this algorithm. So now for 1 to n, we have to screen sorted list from sorted list. Okay, not the previous list, but now the sorted list. We will do n is, see, this is our knapsack. n is, firstly n was 15, nothing was there in our knapsack. Now we are putting some objects in our knapsack. So now n is greater than 0 and this was previously. Now wait, let's say 2. The first object we have to take is object 2, means here. See here, its profit is, let's say profit. See, weight is 4, which is less than 15. So we are putting object 2 here. Then 15 minus 4, 11 is present and profit is 28. So this is done. Put it here. Now move on to our next 4. Object 4 is here. Object 4 has got weight 3, which is less than 11. So 11 minus 3 is 8. 11, yes. And its profit is 18. So you have to add 18 and put this over here. This is also done. Now next is 3. 3 means here, see here, weight is 5. 5 is less than 8. So we are just doing like this. 5 is less than 8, just removing the weight from the actual capacity and adding the profit. This is just a basic concept. It is nothing much, just the basic concept. Okay. So now 3 is left and its profit was 25. And object 3 was, so I think here and here. Then object 5. 5 is here. So now its weight is already 3, so 3 plus 0, and then its weight will be, object 5 will be put here and profit is 9. So total it is coming as, I got also completed there. So whatever it is, total it is coming here. Just put in calculator, just do this and this will be our coming profit. So I hope this is you have understood this. So please practice more on this. I will do PYQs. Please hold on. For now, I will go to next algorithm, Huffman encoding. So this is very important. Okay? I have seen a lot of questions this year. I think in my set there was no question from this, but there are a lot of questions. The questions come from this algorithm. Okay. So be very attentive from now onwards, and please make notes properly. In this way, you see, if you make notes on your own, see, when you are revising, you can just skim through the pages. Okay. So if you take notes from others, I don't know how you will prepare. I have no idea. So many people ask my notes. So these are, first of all, my notes are like this huge. Okay. So even if I give you, how will you prepare? I don't understand this. So please prepare your own notes first, and I'll suggest that, and please practice test series. This is also very important. After PYQs, next you should do is test this. First complete the algorithms. Now here we are doing greedy. I hope you are doing greedy with me, and then you should do PYQs and test series like this. And then we will complete this greedy algorithm once. Then we will move on to dynamic, and that will be end of our day.